Hi everyone, today we are going to start trigonometry. You'll notice that Unit 1 is a lot of review. Most of this stuff you have done before, but you might be a little rusty at it. So we're going to take some time because it's really important that you know the content of Unit 1 to build off of. Unit 1, Lesson 1 is about simplifying radicals, and today we're hoping that you can say at the end, I can simplify, add, subtract, multiply, and divide radicals. So here's what I want you to do first. Without using Google, without using a calculator, without using Siri, will you please pause the video and as quick as you can, no more than 1 minute, fill in what are these values. Fill in these values without peeking. See how many of them you have memorized. So go ahead, pause the video, ready, go. Awesome, so I'm guessing most of you got this first side done. 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared is 64, 9 squared is 81, 10 squared is 100. I'm guessing many of you even got the next two, which is 121 and 144. And hopefully some of you kept going. So 13 squared is 169, 14 squared is 196, 15 squared is 225, 16 squared is 256, 17 squared is 289, 18 squared is 324, 19 squared is 361, and 20 squared is 400. You should memorize these. If you don't have 1 through 20, the squares memorized, you should work on doing that. It's just going to make your life easier. Just like when you were in 4th grade and 3rd grade, you memorized your times tables and your division tables because it made your life a lot easier. You didn't have to rely on your calculator. Same thing here. We're not going to give you a time test, but you should memorize these. So one thing that can happen when you're trying to break down a radical is you might get a perfect square under the root sign. For instance, the square root of 25, we know that is 5. The square root of 49, that is exactly 7 because 7 times 7 is 49. The square root of 121 is 11 because 11 times 11 is 121. So breaking down or reducing or simplifying a perfect square under a radical is pretty easy, but sometimes you're going to get numbers that are not perfect squares. So you can see 28, 50, 75, 32. None of these are perfect squares. These are not perfect squares. So what you're going to have to do is you're going to have to try to simplify this by figuring out, do any perfect squares divide into them? And we'll do some examples of that in a little bit. The third scenario that could happen is maybe you'll get something under a radical that is not a perfect square and no perfect squares divide into them. For instance, think of 21. Think of your list of perfect squares. 1, 4, 9, 16, 25. Do any of these numbers divide nicely into 21? The answer is no, and so root 21 cannot be broken down. You just have to leave it square root of 21. If you typed it in your calculator, sure, you could get a decimal, but that decimal would be a non-repeating decimal, and it wouldn't be an exact answer. Same with 30. None of these numbers divide nicely into 30. Same with 101. 101 is actually a prime number, and so none of these numbers divide into 101. And I could keep going and check, more perfect squares, but none of them will divide into 101. And so these, just to make a little note, no perfect squares divide into these. So they can't be broken down. Another thing that you might run into is you might run into a fraction under a radical. That is not considered simplified. You cannot leave a fraction under a radical. Also, part B, you may not leave a radical in the denominator of a fraction. So this would also not be considered simplified. So let's just make a note. These are not considered to be simplified. You can't leave a fraction under a root, and you can't leave a radical on the bottom of a fraction. In this example, This form is the correct form. It does not have a fraction inside of the radical, or does it have a radical in the denominator? There's no radical down here on the bottom. So this would be considered correct form. It would be considered simplified. So let's try a few. Number 1, part A, it says simplify the radical. Well, I'm thinking about my list of perfect squares, and I know 81 is on that list. So the square root of 81 is 9, and that's our answer. Part B, 28 is not a perfect square. So I'm going to make a little list here. 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25. Do any of these numbers divide into 28? Well, 4 does. So think about 28. If you multiply 4 and 7, 4 times 7 is 28. However, the square root of 4 is a nice number. It's 2. So I can pull that 2 out front. The square root of 7 is not a nice number, and no perfect squares divide into 7. And so 2 root 7 would be my answer here. It would be as simplified as I could make it. So you want to pull out all perfect squares and take their square roots. Think about square root of 11. Do any of the perfect squares divide into root 11 or into 11? I would say no. 11 is a prime number, and so this cannot be simplified any further. We would just leave it square root 11. Let's try a couple more. So 48, is 48 a perfect square? The answer is no. So I want to think about my perfect squares and think about, do any of them divide into it? And you want to pick the one that's the highest. So when I think about 48, I know 4 divides into 48, but so does 16, and 16 is higher, so I'm going to go with the higher one. So 16 times 3 is 48, and so what I'm going to do is I'm going to break that radical apart into radical 16 and radical 3, or root 16, root 3, because 16 times 3 is 48. But the square root of 16 is 4. The square root of 3 would not be a nice number, and no other perfect squares divide into it. So my final answer here would be 4 root 3. Let's try 280. I want you to think about the numbers that divide into 280 that are perfect squares. Sometimes it helps, like, you know, if you're not sure if some of these perfect squares divide into it, sometimes it helps to break it down into, like, I know 280 is the same as 28 times 10. So maybe this will help me. Root 28 is the same as root 4 root 7, because 4 times 7 is 28. And root 10 is the same as 2 times 5. But 2 and 5 aren't helpful. They aren't perfect squares. So I'm just going to leave this root 10, because I don't think any perfect squares divide into 10. But I did break down 28 because a perfect square did divide into it, and that was 4. So the square root of 4 is 2, and then I still have root 7, root 10. I'm going to have to re-multiply those back together, and so my final answer is going to be 2 root 70. 7 times 10 is 70. And that's as low as it can go. No perfect squares divide into the 70. So let's think about 600. I know 100 divides into that, and 100 is a perfect square. So 100 times 6 is 600. The square root of 100 is 10. I don't think any perfect squares divide into 6, and so 10 root 6 is my final answer. Let's practice adding radicals. If I have root 3 plus root 3, that's actually 2 root 3s. That is my answer. 2 root 3 is considered simplified because root 3 doesn't have any perfect squares that divide into it. How about part B? 2 root 5 plus root 5. Well, remember, if nothing's in front of it, it's like a 1. So 2 root 5 plus 1 root 5 is going to be 3 root 5. Again, that is considered simplified. You can only add like terms. So if you look at part C, you can see under the root sign, I have a root 18, and then I also have a root 2. Those are not considered like terms. So what you have to do is you have to try to get them to be like terms. Can you break down 18? Do any perfect squares divide into that? Yes, 9 does. And so really I can write this as 3 out front, and then root 9 times root 2 is the same as root 18. And then I'm still going to tack on my 5 root 2 back here. Now the square root of 9 is 3. And so this is really 3 times 3 root 2 plus 5 root 2. But 3 times 3 can be simplified. So I have 9 root 2 plus 5 root 2. And those are like terms. So when I add those together, I get 14 root 2. And root 2 is as simplified as it can go. And so that is my final answer. Now, one thing that you can kind of keep in mind, think about, here's a little example about adding like terms. Think about 2x plus x. Those are like terms because x and 2x both have an x in them. You end up with 3x. This is very similar. Imagine if you had 2 root 7 plus root 7. You wind up with 3 root 7s. And so just think of it, think of that radical kind of like a variable almost. They work in the same manner. Let's try a couple more like that. So as you can see, root 21 and root 6 are not like terms, but I want to try to get them to be like terms. So I'm going to think about what can I break them down into. Well, 21 is the same as 3 times 7. So instead of root 21, I'm going to change that to root 3 root 7. And then instead of 6, I'm going to change that to root 3 root 2. Suddenly, what happens is I have a root 3 in common. Each of the terms has a root 3 in them. So I can pull that root 3 out front, and then I'm going to have a root 7 and a root 2 left. That is considered simplified. I've pulled out as much as I could that they had in common. So I pulled out a common factor, and then I had to leave the rest in the parentheses. Let's try part E. So again, these are not like terms, so I have to try to get them to be like terms. I'm going to try to get a root 2 underneath instead of a 32. So I'm going to change this. When I think of 32, I think of 16 times 2. So I'm going to leave the 2 out front. Then I'm going to have a root 16 and a root 2 because 16 times 2 is 32. And then I have plus 5 root 2, which was there, and I'm just kind of copying down. Well, the square root of 16 is a nice number. 16 is a perfect square, so I have 2 times 4 times a root 2 plus 5 root 2. 2 times 4 is 8, so I have 8 root 2 plus 5 root 2. And now what I have are two terms that are like terms. And so I can combine those, and it would end up being 13 root 2, and that is as simplified as I can go. Let's work on multiplying radicals. So there's more than one way to do this. You could start breaking these down and that type of thing, but I think in this case it's going to be easier if I multiply 8 times 18, I get 144. So really what happens is I have the equivalent of the square root of 144, which is a nice number. The square root of 144 is 12. So if I can figure out 8 times 18 is a perfect square, it's going to be a pretty quick and easy problem. Let's try part B. 45 times 15. 45 times 15 is 675. So that is not a perfect square. So I have to think about my list of perfect squares and think, do any perfect squares divide into it? I think 25 does. So this is the same as root 25 times root 27. 25 times 27 is 675. So now I'm going to start breaking this down. The square root of 25 is 5. The square root of 27, you know what? 9 goes into that, and 9 is a perfect square. So I'm going to change this into root 9, root 3, because 9 times 3 is 27. So it's really going to be 5 times 3 times root 3, which is 15 root 3. That is my final answer. Now, some of you might have been thinking, wait a minute, 225 is a perfect square, and it divides into 675 also. So instead of breaking it down like I did, what if I would have broken it down into 225 and 3? 225 times 3 is also 675. And the square root of 225 is 15, and root 3 can remain under the root. Either way works. You choose what pops out to you. Next, let's work on simplifying fractions that have a radical on the bottom. So these are not considered simplified because you cannot have a square root or a radical on the bottom of a fraction. So you have to do something called rationalize the denominator. Rationalize the denominator. And so what we do is we look at what's on the bottom of the fraction and we multiply by that number. So in this case, I'm going to multiply by root 3, but I'm also going to multiply by root 3 in the numerator because root 3 over root 3 is 1, and you can multiply anything times 1 and you're not changing its value. So when you multiply these, you multiply the numerators across the top, you get 2 root 3, and on the bottom, you get root 9. 3 times 3 is 9. But the square root of 9 is 3. And so, as you can see, when you multiply root 3 times root 3, you really just get plain old 3. This is your final answer. You have gotten the radical off of the bottom of the fraction, and there is not a fraction under the radical sign. Let's try another one, part B. Now, I could start by rationalizing the denominator and multiplying by root 16 over root 16, but the square root of 16 is just 4. So can't we just change this to 3 over 4? Part C. Here we have a fraction under the radical. So this is not considered simplified. First thing I do is I break it apart. So I have root 5 over root 6. Then I do not want to leave a radical on the bottom of the fraction. So I'm going to multiply by root 6 over root 6. I'm going to rationalize the denominator. On the top, I have root 5 times root 6, which is root 30. On the bottom, I have root 6 times root 6, which is root 36. But the square root of 36 is just plain old 6. Remember, we talked about that. So if you wanted to multiply root 6 times root 6 and just make it 6 right away, that's okay. Let's try part D. So you can see we have root 21 over 18, and we have a fraction under the radical, which is not okay. Can we reduce that fraction, 21 over 18? Yeah, 3 goes into it. So really, this is the same as 7 over 6. 21 divided by 3 is 7, 18 divided by 3 is 6. So simplify first if possible, or reduce first if possible. I'm just going to make a note of that. Reduce first if possible. So we did that. Now we have root 7/6. But we still don't want to leave a fraction under the radical, so we change that to root 7 over root 6. I want to rationalize the denominator, so I'm going to multiply by root 6 over root 6. On the top, I get root 42. On the bottom, I get root 36 or 6. No perfect squares divide into 42, and I know that basically because I've already simplified. Let's try part E. Can 81 divided by 18 be reduced? Yeah, 9 goes into them. So this can change to 9 over 2. 9 goes into 81 9 times, 9 goes into 18 2 times. I still don't want to leave a fraction under the radical, so I'm going to change this into root 9 over root 2. The square root of 9 is a nice number, so I'll change that to 3 over root 2. Am I done? Nope, I still have a radical on the bottom of the fraction, so I have to rationalize the denominator. I'm going to multiply by root 2 over root 2, and I wind up with 3 root 2 over root 4, which is 2. So this is my simplified answer. Notice there's not a fraction under the radical, and there's not a radical on the bottom of the fraction. Sweet, your turn. So will you please try numbers 1, 2, and 3? Go ahead and pause the video, and when you're done trying them, then unpause the video, and I'll show you how to work them out. Number 1, there is a perfect square that divides into 40, and it's 4. So 4 times 10 is 40, but the square root of 4 is 2. So 2 root 10 is considered to be simplified. Number 2, you have to get a like term. So we want to try to change this. Let's leave 3 root 5. Can we change this into something with a root 5? We sure can. 4 times 5 is 20. So this is 3 root 5 plus 4 times square root of 4 is 2 root 5. And then 3 root 5, 4 times 2 is 8, so I have 8 root 5. And this ends up being 11 root 5. Let's try the last one. We don't want to leave a fraction under the radical. So can you reduce 8/7? No. So let's just break it apart. Root 8, root 7. Do any perfect squares go into 8 or 7? Yes. So this is really 4 and 2. 4 times 2 is 8. And I pulled that apart because square root of 4 will be a nice number. So the square root of 4 is 2, so I have 2 root 2 over root 7. But I'm still not done. I can't leave a radical on the bottom, so I'm going to multiply by root 7 over root 7. So I wind up with 2 root 14 over 7. Because square root of 7 times square root of 7 is square root 49, but the square root of 49 is 7. 2/7 cannot be reduced, and so this is our final answer. Well, that wraps it up. Hopefully you can simplify radicals, add and subtract radicals, multiply radicals, and divide radicals. Next, will you please work on Unit 1, Practice 1. If you get stuck or have questions, please send us a Schoology message. Good luck. Have a great day.